All right, so today we're going to look at 4.2, which is now putting everything we learned from 4.1, the determining the end behavior and finding the zeros and multiplicities. We're going to put that together with a couple of other tools we have, which is finding the y-intercept and also using a couple of test points to get a nice sketch of these polynomial functions. Okay, so in this section, we are going to go over graphing polynomial functions using the 6-step process. And then at the end, I'm going to also show you how to use the intermediate value theorem. Okay, now, big, huge note. If you don't hear anything else I say in this video, note to self that this 6-step process is how I am going to be grading your worksheet for this section and also your exam. Okay, so I want to see all of these steps completed in order for you to receive full credit. Okay, so the first one is we want to determine the end behavior. My pen has died. Okay, so we want to determine the end behavior, and remember, we find the end behavior by looking at the leading term, right? If the degree is even, the ends go together. If the degree is odd, the ends go opposite directions, and then the leading coefficient tells us what the right side is doing, right? All right, then we want to find the zeros, okay? And when we find the zeros, we're setting it equal to 0 and solving, so factoring, right? And then once we find all of the zeros and have them written as ordered pairs, very important, then we want to determine the multiplicity. So I want to see that you stated the multiplicity and then whether or not it touches or crosses based on that multiplicity, okay? And then we're going to find those x-intercepts that we just found are zeros. We're going to use that to divide the graph into pieces, right? So we have the piece leading up to our first zero, and then the piece from our first zero over to our next zero, and then our piece from that zero over to the next zero. So we're going to break it up, and we're going to find a test point for each interval to plug in so that we can determine how high up or how high down our loops go. Okay, and then we're also going to find the y-intercept, and then we're going to use all of that information to sketch a graph. Now, one thing to note really quickly is a lot of the graphs that I give you are like a 10 by 10 or a 12 by 12 graph. So if you plug in some value and it says that the y value is going to be, I don't know, 87 or something like that, don't scale this down or don't draw it off your graph and say, oh, up here's 87. Just go ahead and draw it at the top of your graph, and we'll just assume that's where 87 is, okay? Same thing if you plug in a number and you get a really, really low, like negative 67 or something crazy. We're just going to draw that point at the base of our graph, okay? So even if you end up with something that comes up and does something like this and comes back down and, you know, and it's all the way up to the tops of the graph, don't worry about it, okay? It's not a perfect graph. It's a sketch of the graph, okay? But I am looking for all of this information to be found and to be accurately represented on your graph, okay? So here's the problems we're going to do. I'm going to do these 3 examples, and then you can pause the video and work these 3 examples, and then we'll go over them, and then we'll move on to intermediate value, I can't say it, intermediate value theorem, okay? So let's go ahead and look at some examples. First example, before I get started finding zeros or anything, I want to determine the end behavior, right? What's going on at the ends. And to determine what's happening at the ends, I look at my leading term. So in this case, my leading term is negative 2x to the 4th, right? It's an even degree. Even degree tells me that the ends are going the same direction, right? And because I have a negative leading coefficient, that tells me that the right side is going down. So if the right side's going down, excuse me, and the ends are going the same direction, then that means the left side's going down. So we have a graph that looks something like that, right? We don't know what's going on in the middle. So I'm looking for you to write everything that I'm writing, okay? Tell me about the ends, tell me the right side, and then sketch a little picture, because once we graph ours, we're going to look back and make sure that it matches, okay? All right, so now we can move on and look for our zeros. This one is not factored for us, so we need to set it equal to 0 and find our factors. So negative 2x to the fourth plus 3x cubed equals 0. Now I only have two terms, but these are not perfect square terms and they're not perfect cube terms. So the only thing I can hope to do with a two-term polynomial is to take out a greatest common factor, right? So greatest common factor, I can take out an x cubed. When I take out an x cubed, that leaves me with negative 2x plus 3 is equal to 0. So now this is fully factored, so I'm going to set each factor equal to 0. And since this is just an x cubed, really the x is what I need to set equal to 0, and the cubed actually tells me that I have 3 copies of that. So that's my multiplicity. So this one would have multiplicity 3. Multiplicity, when it's odd, means it crosses at that x-intercept. So this means it crosses at 0, 0, right? And then I look for the next one. I set this one equal to 0, negative 2x plus 3 equals 0. I move my 3 to the other side, so I get negative 2x equals negative 3, and then I divide off my negative 2. So I get x equals 3/2. It has multiplicity 1 because it came from this factor, and I only have one copy of that factor, right? So it is going to cross at this x-intercept, which is 3/2, 0. Okay, so this is the information I'm looking for each 0 that you find. Okay, all right, so now we have it completely. So this is everything we did in 4.1, right? Determining the end behavior, finding the zeros, and the multiplicities. What we're going to add in today is finding the y-intercept, because that gives us an additional point to plot. And to find the y-intercept, we are going to set x equal to 0. Now, you can set x equal to 0 here in your factored version, or you can set x equal to 0 in the original. It doesn't matter. I'm just going to use the original. So we get y is equal to negative 2 times 0 to the 4th power plus 3 times 0 cubed. Notice I have a 0 in each term, so the whole thing is just going to end up being 0. So my y-intercept is 0, 0. Okay, even if you can determine the y-intercept just by looking at it, I still want you to write it as one of your steps and identify it as an ordered pair. Okay, all right, so now comes the part where we need the additional points. Okay, that's the other new thing for today, is to find our test points. Okay, so I'm going to do it. Normally I would do it down here at the bottom of the page, but then I don't think you can see all of my work at once. So I'm going to do it over here. So the last thing is to find test points. So I'm going to go ahead and put my zeros on the graph. So I have one at 0 and I have one at 3/2. Now 3/2 is 1.5, right? Or 1.5. So I'm going to go ahead and just kind of guesstimate that on there. So these zeros have broken up my x-axis. So I have the x-axis from negative infinity up to 0. I have from 0 to 1.5. And then I have from 1.5 on. So those are the 3 intervals that I need to have test points for. So negative infinity up to my first 0, which is 0. And then my next 0 over to 1.5, or you can write it as 3/2. And then from 3/2 out to infinity. Okay. So these are the intervals that I want to pick an x value for. Okay. So I want to pick an x so I can determine the corresponding y. Because if I pick an x, y, then that gives me a point I can graph, and I can see how high up or down my function goes. Okay, so I'm going to pick an x that falls within this interval. So basically I need a number less than 0. So I'm just going to pick -1. Then for this interval, I need a an x that's between 0 and 1.5. So between 0 and 1.5, I'm just going to pick 1. And then something that's bigger than 1.5, I'm going to pick 2. Okay, so now I'm just going to take those 3 numbers and plug them back into my function to see what the y value is going to be. Now again, you have a choice. You can take these and plug them back in up here to your original, or you can plug them in to your factored version. Okay, I'm going to plug them into the factored version just because I feel like I can do it a little bit quicker in my head. Okay, but either one is totally fine, whichever one you're more comfortable with. So if I plug in -1, f of -1, this factored version says that I take my input cubed, so I'm going to do -1 cubed times, inside here, I'm going to do 2 times -1 plus 3. So -2 times -1 plus 3, right? And then I'm just going to simplify that, okay? And I'm actually going to write that I'm using the factored version here so I don't have to keep writing it all down. There we go. Okay. So now I just need to simplify this, right? So -1 cubed is -1. And then inside this quantity, I have -2 times -1, which is a +2, plus 3 is 5. So -1 times 5 is -5. Okay. Now I want to do the same thing for +1. F of +1, I'm going to put +1 in and cube it. So +1 cubed, and then -2 times +1 plus 3. +1 cubed is +1. And then in my parentheses, -2 times 1 is -2, plus 3 is 1. And 1 times 1 gives me 1. And then I want to do it for 2. So f of 2, I'm going to plug it in. So I'm going to do 2 cubed times -2 times 2 plus 3, and simplify. 2 cubed gives me 8. And inside my parentheses here, -2 times 2 is -4, plus 3 is -1. And 8 times -1 is -8. Okay? All right, so I'm going to move this back down. So I'm going to go ahead and plot these ordered pairs. So when x is -1, I'm down at -5. When x is 1, I'm up at 1. And when x is 2, I'm down at -8. Okay. So this should make some type of a parabola. So notice when I connect my dots, there's a couple of things I want to check for. The first thing is, does my end behavior correctly represented like it was on my first step over here? Both ends down, both ends ended up down. So that's good. The other thing I want to check is, do my zeros have the behavior that they're supposed to have? So my zeros say that it should cross at both of these x-intercepts. And notice they did in fact cross to come up to this positive point and then cross to come back down to this negative point. So everything turned out good, and that's all we have to do. Okay. Now, if you graph this on your graphing calculator, it may look a little bit different, right? It might come up just a little bit higher here. It might have a little wiggle kind of in there. But again, we're just doing a sketch. So the sketch I want you to have includes your test points and your zeros and mimics the correct end behavior. Okay, that's what I'm looking for, not a perfect graph. Okay. All right, let's look at another one. So on this one, before I start doing anything, I want to determine my end behavior. So what's happening at the ends is determined by my leading term, which in this case is 2x cubed. It's an x cubed, so that's degree 3, which tells me that my ends are going opposite directions. And then my leading coefficient tells me what the right side's doing. Here, since it's positive, that means the right side's going up. So if the right side's going up and the ends are opposite, that means the left side must be going down, and then we don't really know what's going on in the middle, right? You can use a dotted line or a squiggle or whatever. But I just want to see that you have that in behavior, okay? Now we can go ahead and move on to find our zeros. This one was not factored for me, so I need to set it equal to 0 so that I can factor it. So 2x cubed plus x squared minus 8x minus 4 equals 0. I always look for a greatest common factor, and here they don't have anything in common. So I go straight into my factoring method, which in this case is grouping because I have 4 terms. So I'm going to group those two and those two. Out of my first grouping, I can take out an x squared. And remember, when you divide out an x squared, you should still be left with 2 terms. If you have 2 terms here, you should have 2 leftovers. So 2x cubed divided by x squared leaves me with just 2x. And then x squared divided by x squared leaves me with a positive 1. Okay? And then out of the second pairing, they're both divisible by a negative 4. So if I take out a negative 4, that's going to leave me with 2x plus 1. And now they both have that 2x plus 1 quantity. So when I take out 2x plus 1, I'll be left with x squared minus 4. And now it looks pretty factored, but I can actually factor it a little bit further, right? Because this one isn't all the way down to a regular x. It's an x squared. So that implies I should be able to go further, right? I have two terms. They're both perfect squares, and I'm subtracting them, which means that this is a difference of squares. Okay? And my base that's being squared here is an x. My base that's being squared here is a 2. So this should factor into x plus 2 times x minus 2. Okay, and then don't forget to bring your other factor down here, 2x plus 1. Okay, all right, so I have it completely factored, so I should be able to see what my zeros are. If I solve this one, 2x plus 1 equals 0, I'm going to move my 1 over, so that means 2x equals negative 1, right? And then I divide off my 2, so x equals negative 1/2. When I solve each of these, I'm going to get x equals negative 2, and here I'm going to get x equals positive 2, right? So there's my three zeros. Now I need to determine their multiplicity and whether it touches or crosses, okay? So if I look at these three zeros, they came from these three factors. And notice I don't have multiple copies of any of these factors. I have one of that factor, one of this factor, and one of that factor. So they each have multiplicity 1. So I'm going to go ahead and say multiplicity 1, and I'm just going to say that goes for all three of them. And if they all have multiplicity 1, then that means they all cross the x-axis. Okay. Now I do want to go ahead and write each of their individual x-intercepts. So this would be negative 1/2, 0. This would be negative 2, 0. And this would be 2, 0. Okay. So here's all the information that I need when I'm grading to make sure that you have. Okay. So I'm going to go ahead and put my zeros up here. I have negative 1/2, I have negative 2, and positive 2. Okay. All right. So now we need to find our y-intercept. Our y-intercept we find by setting x equal to 0. And I'm going to go ahead and do it in my original, right? Because if I set x equal to 0, I can see here that all these terms are going to go to 0, right? If I plug 0 in, that term becomes 0, this term becomes 0, that term becomes 0, and I should just be left with a negative 4, right? So when x equals 0, y equals negative 4. So that's going to give me the y-intercept 0, negative 4. Okay? All right, so we're almost done. I'm going to go ahead and put my y-intercept on here, which is negative 4. And now the last thing I need to do is find some test points to make sure my shape looks the way it needs to look. So test points for all these intervals. So my first interval is from negative infinity up to my first 0, which is at negative 2. So negative infinity to negative 2. And then negative 2 over to my next 0. So negative 2 to negative 1/2. And then negative 1/2 over to my next 0, which is at positive 2. And then from positive 2 on out to infinity, because I don't have any other zeros out there. Okay, so these are the intervals that need test points. So I'm going to go ahead and pick some x's to plug in so I can figure out what their y values are. Okay, so picking an x smaller than negative 2, I'm going to pick negative 3. Picking an x between negative 2 and negative 1/2, I'm going to pick negative 1. Something between negative 1/2 and 2, I'm going to go ahead and pick 0. If you pick 1 or 1/2 or negative 1/4, any of that, it's going to work. I'm picking 0 because we've already done it. That was our y-intercept. So we already know this is negative 4. Okay. Something bigger than 2, I'm going to pick 3. So now I only have 3 values that I need to plug in. And when you plug them in, remember, you can use the factored version or you can use the original, whichever one you like best. I'm going to use the factored version. So my function, which is h of x, not f, when it's factored out, is 2x plus 1 times x plus 2 times x minus 2. Okay, and I'm going to evaluate h of negative 3. So I'm just going to think through it, okay? When I plug negative 3 into this first quantity, negative 3 for x, so negative 3 times 2 is negative 6, plus 1 is negative 5. When I plug negative 3 into this quantity, negative 3 plus 2 is negative 1, and negative 3 minus 2 in this last quantity is negative 5. Okay? So when I multiply all these numbers together, I have 3 negatives, so it's going to end up negative, and 5 times 1 times 5 gives me a negative 25. Okay? Then I want to do the same thing for negative 1. H evaluated at negative 1, so now I'm plugging negative 1 in for x. So 2 times negative 1 is negative 2, plus 1 is negative 1. When I plug negative 1 into the next quantity, negative 1 plus 2 is a positive 1. And then over here, negative 1 minus 2 is negative 3. Okay? So then I multiply these together. I have 2 negatives, which is going to make this a positive. So 1 times 3 gives me a positive 3. And then I just need to plug in 3. So h of 3. When I plug a 3 in here, 3 times 2 is 6, plus 1 is 7. In my second quantity, 3 plus 2 is 5. And in my last quantity, 3 minus 2 is 1. And when I multiply 7 times 5 times 1, that gives me 35. Okay. All right, so now I want to go ahead and plot these points on my graph here. So at negative 3, I'm down at negative 25. Well, that's off the graph, so we're just going to put it right here at the bottom. At negative 1, I'm up at 3. So negative 1 up at 3. I already have my y-intercept. And then at 3, I'm up at 35. So 3, I'm way up here. 35. Okay. So now I want to connect all my dots and see if I get this type of shape. So I'm going to come up here. When I get to negative 2, it's going to cross. And then I'm going to come back down to negative half and cross. Hit my y-intercept, come back up, and cross again at positive 2. Okay. So my function looks something like that. Okay. If it's not perfect, that's okay, but try your best to connect nicely. So notice our shape matches our end behavior, and we're crossing at all 3 zeros, which is what we were supposed to do. Okay? All right, let's look at one more, and then I'm going to let y'all work on some practice problems. Now, in your homework, this one was really nice. It says, hey, look, here's the big ugly that we're gonna work with, and here's what it is factored. Yay! But I've noticed in your homework, sometimes they give you a problem that just looks like that. They just give it to you factored. They say this equals g of x. Okay? And if they don't give you what it equals all multiplied out, I don't want you to have to distribute this whole mess to figure out what the leading term is, right? Because if we're going to look for our end behavior, we need to know what that leading term is going to be, right? Well, the leading term is what we get when we multiply all this out. So I just want to kind of think about what we would get instead of having to distribute it all out. So I'm going to look for the leading term in each quantity. So the leading term in here is the x, right? It's the term that has the highest power of x, which in this case is just a 1. So whatever the leading term is here, it's going to contribute to the overall leading term when I distribute this out. So this one's going to contribute an x, right? Now this one, its leading term is also an x, but notice it comes from a squared term. So when I do x minus 2 times x minus 2 and start multiplying that out, my highest degree term from that is going to be an x squared. Okay. And then my last factor over here, my leading term is an x. And notice it's not squared or anything out here. So this is going to contribute an x. Okay. So if I multiply this x by this x squared by this x, I'm going to end up with x to the fourth. So that means my leading term would be x to the fourth plus, and then we'd have a whole bunch of other stuff, right? So you can see here when I move my finger, our leading term is indeed x to the fourth. I just didn't figure out what all this other stuff was because I don't really care, right? All I need to know is what that leading term is so I can figure out my end behavior, okay? When you're doing this on your homework, if there is a number in front of these x's, that will also contribute. Or if there's a greatest common factor in front here, that will also have to be multiplied on to your leading term, okay? If they give you a nice one like this, you don't have to do all that. You just look and see what the leading term is, right? Okay, so my leading term is x to the fourth. Since it's degree 4, that tells me that the ends are going the same direction. And my leading coefficient, if there's nothing written there, it's an implied 1, right? So that's positive, so that tells me that the right side should be going up. So if the right side's going up and the ends are going the same, then that means the left side's going up, and we don't really know what's going on in between, right? All right, so now that we know our end behavior, now we want to go ahead and find our zeros. Our zeros, in this case, this one was factored for us, right? I don't have to take this and factor it. They already told me what it equals. So I have x plus 1 times x minus 2 quantity squared times x minus 4, and all I have to do is set it equal to 0. So I'm just going to solve each one. So when I solve here, I get x equals -1. It came from a factor that only had one copy. So that means it has multiplicity 1. 1 is odd, so that means it crosses at that x-intercept, which would be -1, 0. So there's everything I need to know about that guy. Now I want to move on to this one. This gives me x equals +2. Notice it comes from a factor that's squared, so that means its multiplicity is 2. So that means it's going to touch at that given x-intercept, which is 2, 0. So there's all the information I need on that one. Then I look at this one. I get x equals +4. It came from a factor that I only have one copy of, right? So its multiplicity is 1, which means that it crosses at that x-intercept, which would be 4, 0. All right, so I have all the information on my zeros. I'm going to go ahead and plot them as x-intercepts. So -1, +2, +4. Okay. All right, let's find our y-intercept by setting x equal to 0. Again, when we find our y-intercept, this should be relatively easy if we have it multiplied out, right? If we have it multiplied out, you can see this term's going to go to 0, 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 and we should get -16, right? But I'm going to show you, just in case you get one on your homework that just looks like that, how you can find the y-intercept, okay? We still just plug 0 in everywhere we see an x, okay? So g evaluated at 0 would give me, plugging it into the factored quantities, 0 plus 1 times 0 minus 2 squared times 0 minus 4. And then I would just simplify. So this gives me 1, this gives me -2, and I'm squaring it, so that gives me a +4. And then this last quantity, I have a -4. So when I multiply 1, 4, and -4, that does in fact give me -16. So my y-intercept is 0, -16. Make sure you write it as an ordered pair. Okay. All right. And then the last thing we need to do is our test points. Oh, and since our y-intercept is off the chart, right, this is only an 11 by 11, we're going to go ahead and just write it right down here at the bottom. Okay. All right. So our test points, we're testing the intervals in between all of our zeros. So our first one is from -infinity up to our first 0, which is at -1. -infinity to -1. And then from -1 over to our next 0, which is at 2. And then from 2 over to our next 0, which is at 4. And then 4 out to infinity, because it was our last 0. Okay. So we need to pick an x value for each of these so we can find the corresponding y value. And I'm actually going to plug this into the factored version. So I'm going to go ahead and just write my function here. G of x is the same thing as x plus 1 times x minus 2 quantity squared times x minus 4. Okay. All right, so we need a test point that's smaller than -1, so -2, something between -1 and 2. I'm going to pick 0 because we've already done that. That's our y-intercept, so -16. Something between 2 and 4, 3, and something bigger than 4, I'll pick 5. So I need to plug in these 3 numbers into my function and figure out what they equal. So I'm going to go ahead and start with finding g evaluated at -2. And again, I'm just going to kind of think through it. If I plug -2 in here, -2 plus 1 is -1. If I plug -2 in here, -2 minus 2 is -4, and it's squared. -4 squared is +16. And then -2 in the last quantity, -2 minus 4 gives me -6. So when I multiply together -1, 16, and -16, I end up with a +96. Now that's definitely off my graph, so I'm just going to write it at the top. So at -2, I'm maxed out up here at the top. Okay. Now let's plug in our next number that we need a y value for, which is 3. So if I plug 3 into my g function, 3 plus 1 is 4. In my next quantity, 3 minus 2 is 1, and then I square it. 1 squared is still just 1. And then 3 into my last quantity, 3 minus 4 is -1. Okay. So 4 times 1 times -1 is going to give me a -4. Okay. And then the last one I need to plug in is 5. So g evaluated at 5. When I plug 5 into my first quantity, 5 plus 1 is 6. When I plug 5 into my second quantity, 5 minus 2 is 3. Squared gives me a 9. And then 5 into my last quantity, 5 minus 4 is 1. Okay. And then 6 times 9 times 1 is a +54, which is maxed out at the top, right? All right, so I need to go ahead and graph these last 2 points. So at 3, I'm down at -4. And at 5, I'm all the way at the top of my graph. All right, so let's go ahead and connect these dots and see if it gives us this kind of shape with the zeros touching and crossing as they should. So I'm going to stop up here, start up here, not stop. Start up here at this really high point up at x equals -2. It's going to come down, it's going to cross at -1. And it's going to come hit my y-intercept way down here. And then it's going to come up to my x-intercept at 2 and just touch it. And then come down to this point. And then go back up and cross through 4 to end up at this point way up here. So we should be getting kind of a W shape. For Williams! Yay! Just kidding. It only works because my last name is Williams. Okay, so that is the 3 examples that I wanted to do. So go ahead and pause the video, and on the next 3 pages, there are 3 for y'all to try. Go ahead and give those a try, and if you get stuck or whenever you're ready to go over them, unpause it, and we'll go over them. All right, let's see how you did. So on the first one, your leading term is -x cubed. The cube tells me the ends are opposite. The negative out front tells me the right side down. So our end behavior should look something like this. Then we set it equal to 0 and factor it by taking out a greatest common factor. Now, whether you took out a -x squared or just a regular x squared, you should still get the same zeros as I did. So x equals 0 with multiplicity 2 because it's an x squared, and x equals -2 with multiplicity 1 because we only had 1 copy of that factor. Okay, so it touches at 0, 0, crosses at -2, 0. My y-intercept is going to be 0, 0, 1 because I already know I got that as an x-intercept. But also if you plug that into either of these quantities or the original, you're going to get 0 for your y. Okay. And then we need to pick test points smaller than -2, between -2 and 0, and larger than 0. I picked -3, -1, and 1, and you should get 9, -1, and 3 as your outputs. So your shape, once you graph it, should be this nice little swoosh, which does in fact match our in behavior, and it does cross at -2 and touch at 0. Okay. If you need to pause that and work through it a little bit, feel free to do so. But we're going to go ahead and move on to the second one. Okay. So our second one, this one is not distributed out for us, so it's a little bit hard to see what our ends would be. So looking at this first term, we have an x, so that's going to contribute to our leading term. And then with all the other quantities, we also have an x that's going to contribute, right? None of them are squared or anything like that. So we're just doing x times x times x times x, which is going to give us an x to the fourth. Fourth degree means the ends go the same direction. Leading coefficient of a 1 means that both ends go up, right? Right side goes up. All right. And then our zeros, when we take this mess and set it equal to 0, luckily it's factored for us. So we just have to determine what each 0 is. So we should get 0, -1, 2, and +4. They all have multiplicity 1, which means they all cross at their respective x-intercepts. Okay, I'm fine with you using shorthand if they all have the same thing, but I do want to see that you wrote each individual x-intercept because it should be represented as an ordered pair. Okay, our y-intercept is 0. Again, if you plug a 0 in for x, this first one being 0 is just going to make everything else 0. Okay, and then we need test points. Between leading up to -1, I picked -2. Between -1 and 0, I picked -0.5. Between 0 and 2, I picked 1. Between 2 and 4, I picked 3. And something bigger than 4, I picked 5. So if you pick the same numbers as me, you can check them. I plugged mine into the factored version. Obviously, I didn't multiply it out. When you are plugging in fractions or decimals, like on this one, picking something between -1 and 0, you could pick any tiny little negative fraction there. You could use -0.1 or -0.5 or -0.99999, right? As long as it falls within this interval, it's okay for you to pick. Once you pick your value and you plug it in, it's fine if you get a decimal or a fraction because we're just using this to get a good picture. Okay. Once you connect your dots, they all cross, should give you another nice W shape. Okay. All right, and then the third and final one, our leading term is an x cubed. So that means that the degree 3 tells us the ends are opposite. My leading coefficient of a +1 tells me the right side's up, which means right side up, left side down. And notice we should be getting something like that. Then we have to set it equal to 0 to factor it. We can factor it by grouping. And then when we get here, notice this is not fully factored. If we get the quantity x squared -1, we can factor that into a difference of squares. Some of you probably took this and just went ahead and set it equal to 0 and did the square root. That's totally fine, but don't forget your plus or minus so you get both zeros, and make sure you know how to write it in factored form. Okay? All right. All of our factors are to the first, right? We just have one copy of each factor, which means all of our zeros have multiplicity 1, so they all cross at their respective x-intercepts. When we look for our y-intercept and we put 0 in for x up here in our original, notice all my x terms go to 0 and I'm left with a -3. And then our test points, you can check. Okay. So again, you do have a worksheet that goes with this section, and the way that I grade the worksheet is looking at exactly what I have written here. Did they determine the end behavior? Did they find the zeros, state the multiplicity, and give me the x-intercepts? Did they identify the y-intercept? Did they do test points? And then did they graph it all accurately? Okay, so don't give me just x equals -3, x equals 1, x equals 1, and then a perfect graph that looks like it came off a graphing calculator, because you won't receive credit. Okay, I'm looking for this process. All right. Okay, so that's graphing. The last thing I want to mention is the intermediate value theorem. So the intermediate value theorem simply states that we are guaranteed to have, let me zoom this in a little bit. We are guaranteed to have an x-intercept if our y values change from positive to negative or negative to positive. Meaning, if I take two little x values, we're going to call this one A and this one B. If I plug in A into my function and I get a negative y value, right? This is down here, so this is negative, right? And then I plug B into my function and I get a positive y value, then that means somewhere between A and B, I had to have had an x-intercept, right? Because the only way I can go from negative up to positive is if somewhere along the line, my graph crosses the x-axis, right? So if my graph crosses the x-axis, that means I had a real zero between these two numbers, right? And the same thing if I did it in the opposite order, right? Let's say I plugged in A and I got a positive value up here, right? And then I plug in B and I get a negative value on this end. Well, if I'm going from positive down to negative, again, somewhere along the line, this would have had to have crossed my x-intercept, which means there exists a real zero. So we can use this intermediate value theorem to see if we're guaranteed a real zero simply by plugging in the two x values they give us. Okay? If their signs are opposite, meaning one negative, one positive, then we know that there's a zero. If their signs are the same, then it doesn't work, right? All right, so let's look at an example. On this one, they give us p of x equals 1/3 x to the fourth minus x cubed. And they're giving us a of negative 1/2 and b of 1/2. So I just need to plug these two into my function so I can see what their signs are. Okay, so I'm first going to evaluate p of negative 1/2. So when I plug negative 1/2 into my p function says to do 1/3 times my input to the fourth power and subtract my input cubed. So I'm just putting in negative 1/2 everywhere I see an x in my original function. And now I just need to simplify this, okay? So I have 1/3 out here, negative 1/2 to the fourth power. That means negative 1/2 times negative 1/2 times negative 1/2 times negative 1/2. So negative times negative times negative times negative is going to give me a positive. And 1 to the fourth is 1, 2 to the fourth is 16. Okay? And then over here I'm subtracting. Negative 1/2 to the third power is negative 1/2 times negative 1/2 times negative 1/2. So I have 3 copies of it, so it's going to end up negative. 1 cubed is 1, 2 cubed is 8. And then I'm going to go ahead and simplify. I'm going to multiply these two together and fix my double negatives. So this gives me 1/48 plus 1/8. Okay, now I really don't need to go any further because I really just care if it's positive or negative, but I think in your homework it actually makes you enter the value for p of negative 1/2. So I'm going to go ahead and just get a common denominator and an answer that I can enter. So my common denominator here would be 48. So I need to write the second one with a denominator of 48, which means I need to multiply the second one on top and bottom by 6, right? So that's going to give me 6/48, which then I can add to 1/48, which gives me 7/48, which is a positive value. Okay, so I got a positive value for my first little one, right? So it's like this one. So in order for there to be a 0 there, I'm hoping that for my b, when I plug it in, there's a negative answer. So let's go ahead and check. If I plug in my b value, which is positive 1/2, into my p function says to do 1/3 times my input raised to the fourth power and then subtract my input cubed. And then we just need to simplify. So I have my 1/3, 1/2 to the fourth power is going to be a positive 1/16. and 1/2 to the third power is going to be a positive 1/8. Okay. Again, when I multiply these, I get 1/48. This time I'm subtracting 1/8, and I'm going to go ahead and get a common denominator again. So 1/48, and this one, to write it as something over 8, I need to multiply by 6 on top and bottom. So I get a minus 6/48, and 1/48 minus 6/48 is going to give me negative 5/48. So I did in fact get a negative answer. So is there a real zero between these two x values? Yes, right? Yes, because it went from positive to negative. Okay. All right, so on the next page, there's 2 for you to try. So go ahead and pause the video and determine if there is a real zero between the given values of a and b, and then we'll go over them. All right, so on the first one, when you plug in -1 to your p function, you should get a positive 6. When you plug in 3 into your p function, you should get a positive 18. Because they're both positive, we cannot use the intermediate value theorem to ensure there is a real zero between these two numbers. So our answer is nope or no. On the second one, when we plug in -4, we should get a -24. And when we plug in -2, we should get a positive 8. So here, because we're going from from negative to positive, then yes, we are ensured to have a real number 0 between these a and b values. All right. Okay, so that is the end of section 4.2. So you should now be able to complete that assignment as well as the worksheet that is over sections 4.1 and 4.2. Okay, the worksheet is just going through the graphing of those problems in the systematic steps that were shown in this video. Okay, if you have any questions, please let me know.